Hello folks, welcome to Chapter 2 of our Basic Machine Operator program. This is the introduction to radiographic equipment. All right, so our learning objectives on this particular chapter is going to be to understanding the use of correct terminology when discussing about X-ray equipment and its parts. You need to be able to demonstrate the radiation field and define the central array or the CR. You also will be able to explain the differences between primary radiation, scatter radiation, and remnant radiation. You also need to understand and list the two effects of scatter radiation. We also will be able to list the components of an image receptor or IR system, list the essential features of a typical X-ray room, and explain the purposes of the control booth and the transformer cabinet. Also safely exchange the positions of the radiographic table and also the X-ray tube. We also need to make sure that everyone can explain the term adverse incident as it relates to radiography and demonstrate a detent and explain its function. Also explain the purpose of a collimator and describe precautions to be taken to ensure personal safety from radiation exposure. All right, folks, let's talk about the primary radiation source. The primary radiation comes from the X-ray tube. The internal structure and the function of the tube is discussed in Chapter 5. The radiation is emitted from the tube in a square fashion called the radiation field. Scatter radiation is the radiation from the primary beam that is randomly scattered within or outside of the body. Remnant radiation is what remains of the primary radiation beam after it has been attenuated by the matter, which the matter or mass is the patient. The image receptor or IR is the system that captures the X-ray digitally into a cassette that contains a phosphor imaging plate. All right, so folks, here we have a very good diagram that's out of your book. It talks about the primary radiation. This is your primary radiation that comes out of the tube. This is the collimator that is here in this area, and this is the X-ray tube itself. All right, so the primary radiation comes, it strikes the patient, it begins going through the tissues, but we have some of it that is scattered, that spreads off the patient. And then you have remnant radiation that goes through the patient, and then the IR is down here in the bottom. That is the image receptor. It contains the latent image of what the X-rays just took. It has the phosphor plate, or the phosphor containing plate that's inside of the cassette and can be changed out and then digitally imaged or digitally processed to create the image. All right, so this diagram illustrates the basic components of the image production system. You have the radiation source, which is the X-ray tube, okay? You have the tube housing, which is lined with lead. That's this guy right here, okay? All right, then you have the tube port, which is where the radiation will pass through. And then finally, you have the X-ray beam. The X-ray beam is what travels from out of the tube port and down towards the patient. You have the central X-ray, which is the primary centered focused X-ray, okay, and which is also the X-ray beam, okay. The central X-ray is the center point. The X-ray beam is everything that's contained within the left and right sides of the central ray. And then finally, you have the radiation field, which is the area to be irradiated are radiated so that you can gather the image on the CR or on the IR, the image receptor. Okay, folks, here we go. Digital imaging is what is used today. I mean, this is our primary computer radiography, our CR cassettes that contain a plate with a special phosphor that stores the image. Those CR cassettes come in standard sizes. A CR reader is used to convert the process of the latent image to a visible image. The image is viewed and stored and retrieved using a computer. So as you can see here in this particular photograph right here, okay, this young lady is putting a IR cassette here into the digital imaging system. Okay, so she's taking the X-ray and then finally it comes up onto the computer after it has digitally processed it into the reader itself. Okay, so it can be looked at by the practitioners. They do come in standard sizes, so they can be utilized in whatever imaging processor that you're using. We'll talk a little bit later, but they definitely come in different speeds. All right, so the X-ray room. Well, it's got to have a control booth. Okay, these are the basic components. It has to have a control console, has to have a transfer cabinet. You need the X-ray tube, and you need the upright cassette holder and a radiographic table. We're going to break these down and talk about them. All right, so the radiographic table, this is this guy right here. Okay, she's got her hands on it right there in that area. This is your upright cassette holder, your cassette that has, this is a cassette that's right here. Okay, it's already loaded with inside. This is the back side of the upright image receptor plate. Okay, the upright cassette table. So you can see that's here. Okay, cassette holder, that's what this guy is on the wall. All right. And then the actual cassette, again, is right behind it in the holder or the bucky system for the cassette. All right. X-ray tube collimator, okay. This is the X-ray tube here. You can see it, it's that round device. And then the collimator is here, okay. Underneath, it's what creates the collimization. The control panel on the collimer is here. Okay, this is the equipment that we're going to use. And this is the console. I really like this particular image. You can see here that this console has already been set up in order to deliver a certain amount of radiation for a particular image. Looking at this, it's already set for, it looks like to be a pelvis. I can't really see it up close, but it's set already as a preset for this particular image to be developed. All right. This is the modern cassette, upright cassette holder. We saw that piece of equipment a little bit earlier on that previous slide. It's a little bit closer look. Now here we go. Now I can see it better. Lovely, 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 lovely. All right, so what we have here is you have your kilovolts set for 70, your milliamps set for your 400, and then the max would be 500 based on an adjustment. And as you can see here, this is a pelvis, okay? This is a pelvis photograph, anterior, posterior, because it looks like it's AP. We've got kilovolts set for 70 and the MA set for 400. And these are presets. Once you select it on the console, it should already be in there for you. So it'll help you. And then it shows you where if you're going to do digital cross-section, you're going to do whole body, what your upper and lower limits could be. And there's your button to actually take, your trigger button to actually do the exposure. Good console, nice digital console, simple, easy to use. Both of these can be adjusted up and down, so it's very, very positive that this particular unit is so easy and so visible to see. You can do your selection on what X-ray you want to take, and the presets are already in there for you. This is the X-ray transformer. This is where all the action happens, where we convert with rectification. We convert the AC to DC. We use thousands of volts for this, 10 to 12,000 volts will end up being converted to be able to use in KVP. These have oil, the rectifiers, the equipment on the inside, the step up, step down transformers are all within the X-ray transformer itself. You don't have to do anything. Cabinet's essential part of the X-ray machine. Its basic function is to produce the high voltage required for X-ray production, as well as the low milliamperage or MAs needed for the X-ray tube. The limited operator's work does not involve with working or setting any requirements on the transformer. All right, so this is a patient. This patient is having a lateral trachea X-ray utilizing the upright bucky system. Note that the cassette in the tray and the X-ray tube is angled at 90 degrees to the unit itself. So here's your bucky. This is the upright cassette holder, and here's your controller with your collimator. Very good. All right, so X-ray tube movement. The X-ray tube may be raised and lowered. It can be moved longitudinally or transversely, swiveled or rotated or angled. So this is your X-ray tube here, okay, and it's on the X-ray machine's arm, okay, here, can go up and down, transverse, longitudinal. You can move it in any direction that you need to move it. X-ray tube features, you have locks, you have the detent, collimator controls, and the collimator light. This helps you get the adequate positioning that you need for the X-ray that you want to produce. The X-ray tube housing has so many different features and attachments. Locking controls are here for the tube and the tube crane. A detent is a special mechanism that tends to stop a moving part in a specific location. The collimator is the box-like device attached under the tube housing. The collimator controls are what is used to control the collimator light and the angles. Table movement. The table may be tilted, moved horizontally or longitudinally. The radiographic table is a very special unit that's more than just a support for the patient. Although it's attached to the floor, it can adjust to 3 types of movements: vertical, tilt, and a floating table, or it can move in any direction. All right, so this is a podiatric X-ray self-contained unit. We don't really see these in other places other than the specialty physician's office of podiatry, because it's very specifically to X-ray the foot and the ankle. So, and it's very, very commonly used in the podiatry world. It is a self-contained or self-contained X-ray machine. Note the control console behind the patient and the X-ray tube and collimator above the foot. All right, some equipment safety consideration. First off, the table and X-ray tube locks are released before attempting to move them. Don't try to force them. You may break something that's very costly. Footboard and the shoulder guard are secured before tilting the table. You don't want patients sliding off your table because you're adjusting the table to the upright position. Table and X-ray tube locks are secure after positioning for them for the procedure. So make sure that table and the tubes are locked into place before you actually do it. Also, any equipment obstacles. One of the most common things that I keep seeing in the hospital when I work there, and also in the urgent care center, is that step stool. Do not slide that step stool to help people up onto the table underneath the table. Because remember, the table can go up or down and it will break the motor or damage the table in some way. Just make sure all the obstacles are clear from the unit or from the table before you move the patient around. All right, radiation protection principles, important stuff. Never hold a patient during a radiographic exposure. Remember, you're exposing yourself. If you have to, you must wear a lead shield gown or apron. I mean, you've got to wear something to protect yourself. We will talk much later in the actual course, talk about how much radiation you can take in a lifetime. So it's very important. If you have to hold the patient, most commonly it is a geriatric patient or a patient with altered mental status or a pediatric patient or even an infant that you're trying to get the X-ray from. If you can, elicit the help from parents if it's an infant or a child, and make sure to put a lead apron on them. Remain within the control booth during all exposures because you're behind a lead wall. Ensure all non-essential personnel are behind the control booth or outside the X-ray room. Ensure the door of the X-ray room is closed before taking an exposure. Remember, scattered radiation can travel, so be sure that that door is closed. And keep the image receptors, the IR cassettes that are not in use inside the control booth. You don't want them to get exposed to scattered radiation, and it'll pick it up onto the IR and then therefore perhaps skew the images that you may be taking in the future on those cassettes. So remember, those cassettes need to be behind the control booth wall. All right, so in summary on this particular chapter, X-rays, they are produced in the X-ray tube and pass through the patient to produce a latent image in the phosphor of the IR. What is the IR? image receptor, and it's a cassette, and they come in various sizes. Mostly they're most common, various speeds, but as far as the shape of them, they're very common. The latent image becomes visible after processing through computer processing. Major equipment in the X-ray room include the X-ray tube, okay, the collimator, the table, the upright cassette holder, and the control console and the transformer cabinet. You can bet you will see this on a test to include IR on the test as well. The X-ray tube and the table may be positioned in a variety of ways. Okay, know those ways. Always use the X-ray tube, table, and ancillary equipment locks appropriately. You'll see that on a test. Be mindful of equipment obstacles that may cause harm to the patient, and protect yourself and others by remaining within the control booth during exposures. Okay, any questions? I wonder if this is a holiday X-ray. We took a visit during Christmas time. Somebody didn't like what was in their stockings. Anyhow, if you have questions, folks, here's where you can email us, student@emeds.net or student@emedciinstitute.com. Thanks for joining me on this Chapter 2 lecture, and we will see you next time. Have a good one.